Lesson 6.2, we're going to look at solving quadratic equations by graphing. And I want you to look at the first thing here, or what I have highlighted in red. Notice that the solutions to the equation are the x-intercepts, which are also called zeros or roots when you're graphing the function. So if they say find the solutions, the zeros are the roots, they are the x-intercepts. So this first example, we're going to end up with two real solutions. So if they ask you to solve the quadratic equation x squared minus 3x minus 4 equals 0 by graphing, okay, we want to really think of graphing the function y equals x squared minus 3x minus 4. Okay, it must be set equal to 0, and then you're going to kind of replace, a quadratic equation is usually set equal to 0, but if we're going to do it by graphing the function, then we replace that 0 with a y. Okay, we're going to make a table here. Now, to determine, remember if it's quadratic, it will be a parabola, and to determine the where we want the middle of our table, remember that the axis of symmetry or line of symmetry, okay, is x equals the opposite of b over 2a. So we're going to actually do that first just to give us an idea of where we want the middle of our table to be. So if I do that here, notice that b is negative 3. This is b right here, but we want the opposite of it, so that'll be positive 3 all over 2 times a. A is what's in front of x squared, which in this case is 1. Okay, so this will be 3 divided by 2, or x is 1.5. So I kind of want the middle of my table to be 1.5. Okay, so it actually ends up being between 1 and 2, or halfway between 1 and 2. Okay, so let's go ahead. That means I want to pick some values on either side of 1.5. So I'm going to pick 1, 0, and negative 1. And I'm going to pick 2, 3, and 4. So actually my vertex, okay, or the x-coordinate of my vertex is right here at 1.5. Now, we're going to pull the table up on our calculator, and unless you change the increments in your table function, it won't actually show 1.5, but we could simply plug in 1.5 to find that particular coordinate. Not that we really need it to find the x-intercepts here, but let's go ahead and plug in then x squared minus 3x minus 4 to our calculator. So, x squared minus 3x minus 4. Let's hit enter, and then let's go. Now you can see on my calculator it's showing the table, but let's hit our table. Okay, so there's what we have. Now remember we said the vertex is at x value of 1.5. As you can see here, we've got at 1 and 2 it's negative 6, so halfway between those would be the vertex, 1.5, and then we can figure that out here, but let's go ahead and fill that in. So take that from your calculator. Let's fill in our table. So at negative 1, it's 0. At 0, it's negative 4. At 1, it's negative 6. At 2, it's negative 6. At 3, it's negative 4. Okay, and at 4, it's 0. So to find the actual value at 1.5, you could go plug 1.5 in here and do 1.5 squared minus 3 times 1.5 minus 4. But I'll show you on the calculator how you change your increments. So if I actually went to my calculator, and this is an 84 here, but if I went to my table setup, okay, right now my x's were going by ones. I want my change in my table, which is kind of the second line here, to be going, because I notice it's going to be at 1.5, I want to go by 0.5s. Okay, so, and the other thing you can do is set up and ask for what the value is, but let's go ahead and do that in our table and pull our table back up. So now notice at 1.5 it's negative 6.25. So let's go ahead and put that one on there. So at 1.5 it's at negative 6.25, so down a quarter of a unit from negative 6. So if I graph these, negative 1, we're at 0. 0, we're at negative 4. 1, we're at negative 6. Okay. At 2, we're at negative 6. Remember, at 1.5, we were at negative 6 and negative 6 and a quarter. At negative 2, we're at negative 6. At 2, we're at negative 6. At 3, we're at negative 4. Remember, with a parabola. And then at 4, we're at 0. So the parabola will look like this. Okay, so the solutions are the x-intercepts. So it would be there and there. So that would be at x equals negative 1 or x equals 4. 2 solutions or roots to that one at negative 1 and at 4. Okay, let's take a look at this one. Now, the first thing I want you to notice about this, what's different from the last one is, do you see you have this negative 4 right here? Okay, we've got to get the quadratic set equal to 0 before we plug it into y equals, make it a function, and plug it into y equals. So we are actually going to add 4 to each side. So here's what I'd have. Okay, let's go ahead and do x equals the opposite of b over 2a, kind of to see where the middle of the parabola is. So I'm going to do the opposite of b. B is negative 4. So I want the opposite of that, that's 4. All over 2 times a. A is 1 here. Okay, so we're going y equals x squared minus 4x plus 4 is what we're going to put into y equals here in a little bit. So it's x equals, this is 2. 4 divided by 2 is 2. So the middle of your parabola is kind of here at x equals 2. Okay, that's the line of symmetry. Okay, so we know when we do our table or get our table from the calculator, 2's got to be in the middle, and I'm going to go, actually I'm going to go 1 and then 0, smaller than it. And then I'm going to go 3 and 4. So let's go ahead and enter this into y equals. Go in and change our other one. I'm going to go back and change my table set to go by increments of 1 here. So let's enter, and let's change that to 1. And then let's go to y equals, clear that one. And now we're going to enter x squared minus 4x plus 4. Okay, let's pull up the table. Now if you notice, as you can see the graph here of the parabola, the vertex is actually on the x-axis, but let's pull up the table, get that filled in. So let's go second, table, and fill that in. As you can see, you can scroll up and down in the table. I'm going to go back to this screen. So if we put those values in, at 0 we're at 4, at 1 we're at 1, at 2 we're at 0, at 3 we're at 1, and at 4 we're at 4. So if I plot those points, I'm going to plot 0, 4, which is right there. At 1 we're at 1, at 2 we're at 0, at 3 we're at 1, and at 4 we're at 4. Okay, so this one doesn't actually go through the x-axis in 2 places like the last one did. This one touches the x-axis in 1 place, which means 1 solution. Okay, the solution is an x value of 2, so it's x equals 2. So 2 is a solution to this quadratic equation. Okay, let's look at this. This is a word problem. Find 2 real numbers whose sum is 4. Sum means we're going to add here. And whose product is 5. Product means multiply. So you have to know what those words mean, or review what those words mean. Okay, so I'm going to let x be one of my numbers. That's one of my numbers. Okay. Now, I'm going to take the fact that I know that the 2 numbers have to add up to 4. If one of them is x, then the other number has to be the sum, which is 4, minus x. Okay? In other words, if one of my numbers was 1, then to find the other one, I'd do 4 minus 1. So if one of my numbers is x, I do the sum minus what the other number is, because we got to get them represented in terms of x. Okay? Now, there's how I represented my two numbers. The product of these two numbers, product means I'm going to multiply, is 5. So I'm going to take kind of my first one here, and how I represented my second one, I'm going to multiply them. So x multiplied by the second one, which is 4 minus x, now notice I got to put that in parentheses, is 5 or equals 5. Now I need to simplify the left-hand side. I'm going to distribute, so 4x minus x squared is equal to 5 when I distribute. Now I'm going to set it equal to 0. I want you to notice that my x squared is negative. We don't want the x squared to be negative. I'm going to make it positive. So I'm actually going to add x squared to both sides to get rid of it here, and then I'm going to subtract 4x, and I'll do that in this same step here. And I'm making the left-hand side 0 then. Now I'm looking at these three terms, so I want to put my x squared first, which is now positive, which is what I want. Then I'm going to put my x term next, which is minus 4x, and then I'm going to put my constant, which was the 5 that started over there, last, and it's positive 5. So I now have that set equal to 0. Okay, let's make our table. Let's go ahead and put that one in there. If you make your table, let's actually do our middle of our parabola, x equals negative b over 2a first. So that would be 4 all over 2 times a, which is 1, 4 divided by 2. So the middle of the parabola is at x equals 2 again, kind of like on the last one. Okay, so we know the middle of our table has to be 2. So let's go ahead and put in x squared minus 4x plus 5. So let me go back. Let's clear this one out. X squared minus 4x plus 5. Enter. Let's pull up the table. Okay, so we're looking at 2 being the middle there. So at 2, we're at 1, which is kind of in the middle of my table. So at 2, I was at 1, and then I'm going to put 1 and 0 for x value smaller than the vertex. This will be 2, this will be 5. And then from your calculator, this is 2, and this is 5. And again, if you don't have a graphing calculator, you have to plug each of these x values in by hand after you find kind of the vertex or the middle of your parabola. You could plug each of the values in. It just takes a little more work if you don't have a graphing calculator. Okay, so let's go ahead and plot those. So I have 0, 5. I have 1, 2. I have 2, 1. I have 3, 2. And I have 4, 5. So if you notice, the solutions are the x-intercepts. That parabola does not go through the x-axis. Okay? It doesn't touch the x-axis at all. It's a parabola that opens up, that's above the x-axis. So that is a no solution because there is no, or there are no x-intercepts. Okay? So that's a no solution. So these numbers do not exist. There is no number whose sum is 4, two numbers whose sum is 4 and product is 5.